All right, class, this is lesson 9.3, and we're going to multiply polynomials. Really, really important lesson, and this lesson will come into play for the rest of your math career. So very, very important that you pay attention, although I will tell you this, I don't think there's anything difficult today. I don't think there's anything hard. Really, the main aspects of what we're doing, we've already learned the concept, so we just have to put it together in the situation of polynomials. Okay, so very, very important lesson. Pay attention. Hey, the video's here. You can come back and watch it again if you're struggling over any area here. But really, really important lesson. But again, one I think is fairly easy and one that I think you can learn quite well. All right, multiplying polynomials. What's the key to multiplying polynomials? And the key is the distributive property. So I'm going to say distribute. That's the key. Distribute. Distribute. Hey, we know the distributive property, right? We do. So here's an example to the right here, right, of the beginnings of the distributive property. And we know when we have an A, something out in front of a parentheses, that it's multiplication, and it's multiplied times the whole parentheses. How do we do that mathematically? Whoops, sorry about that. How do we do that mathematically? Well, we take the A, and multiply it times the first thing in the parentheses, so that would be A times B. All right, and then we take the A and multiply it times the second. Positive A times a positive C gives me a positive A times C, the distributive property. All right, we've done it many times. We've used it already. So that's the aspect of multiplying polynomials. That's the principle, and you'll see it applied many times over as we go through the lesson today. All right, so let's take a look at the first scenario, and that's a monomial. Remember, one term, right? Monomial times a polynomial. So if you look at example A, here's the monomial, negative 3x, and here's the polynomial, in this case, a binomial. Now, it could be a binomial, two terms, trinomial, three, or even more, right? So we have a monomial, negative 3x, times a binomial. How do you do it? Straight distributive property. What is a 3x times a positive 5x? Well, remember, coefficient times coefficient, variable times variable. Negative 3 times 5, negative 15. What is x times x? And I hope you're thinking x squared. So we have the first term, negative 15x squared. Let's distribute to the second. All right, first off, negative 3 times a negative 7. Remember, include the sign with the back number. Negative 3 times a negative 7 is a positive 21, and then times the x, right? And that's the solution. Negative 15x squared plus 21x. Pretty simplistic. Not a whole lot there. Pretty easy. Let's do the second example. All right. So again, if you want to do it on your own, go ahead and pause the video, and then you can turn it back on and see how we did it. All right, so we've got the situation negative 2ab squared. So a little bit more intricate monomial in front, right? And now this time we have a trinomial. So a monomial times a trinomial. No big deal, right? We're just going to distribute. That's all we're going to do is we're going to distribute. So I'm taking this negative 2ab squared times my 3a squared. All right, negative 2 times a 3, negative 6. A times a squared, a cubed, and you still have that b squared from the front. Negative 6, a cubed, b squared. Okay? First distribution. Here I'm going to do my second in green. Second distribution. Negative 2 times a negative 4, positive 8. A times a squared. B squared times b cubed. Right? We've done these aspects by themselves already. I'm going to do the last distribution in blue. Negative 2 times a positive 1, not shown, right? The 1's not shown, but we know it's there. So a negative 2 times a positive 1 is a negative 2. The a is just there because times a, and then b squared times b squared, b to the fourth, and there is your resulting trinomial. Okay? Hey, piece of cake, monomial times monomial. All right, let's get to the new stuff, the nitty of the gritty, really. A binomial times a binomial. These happen all the time in math, all over the place, all the time. A binomial times a binomial. And so it's important that we're very, very good at these. And really, like everything else, the key is distribute. You just have to distribute. That's all. Okay, so if you notice example A, right? I've got a binomial here in front times a binomial in the back. Binomial in the front times a binomial in the back. Oh, excuse me, sorry about that. All right, so don't write this. Don't write this. Technically, what you have is this front variable, again, don't write this, times the whole back, plus the second part of that first binomial times the whole back. That's what's going on. Okay, you follow? You have the front x times the whole back binomial, and the back of the front of -3 times the whole back binomial, 2x plus 5. That's what's going on. That's what's here, and that's what we're dealing with, okay? So how do we do this mathematically? What's the methodology? All right, the methodology is very, very simple. We're distributing. So take your red. All right, let's go ahead and do this now. Let's take our first x, and we're going to distribute it to the back binomial. What's x times 2x? And I hope you're thinking 2x squared, okay? What is x times a positive 5? And I hope you're thinking of positive 5x. All right, I'm going to take my green for the back. Now remember, include this negative sign. Now I'm going to do this distribution over the top so it doesn't muddy the water and it's clear. What's a -3 times a 2x? A -6x. By the way, I'm going to put it underneath my 5x. I'm going to line these up because they're like terms, aren't they? Don't do this in your notes, but look right here. Aren't they like terms? Sure they are. So we're going to add them up in a moment. All right, let's finish the last distribution. What's a -3 times a positive 5? It's a -15. Now we can go ahead and write our final answer. 2x squared minus x minus 15. Final answer. Multiplying binomial times binomial. Now, at this point, let me pause and mention to you a methodology, or really something that math teachers tell students to help them to remember to multiply a binomial times a binomial. And a lot of math teachers love this, and a lot of students love this, and it's called FOIL. FOIL. And FOIL is an acrostic for how to distribute. Now, I don't teach FOIL because I teach you how to distribute. And if you know how to distribute, you can multiply any polynomial times any polynomial. But if you learn the FOIL, you can only do a binomial times a binomial. So I want you to learn how to multiply any polynomial times any polynomial. And therefore, I don't teach FOIL. But I am going to mention it to you so you are aware. FOIL stands for first, outer, inner, and last. That's what it stands for. So if you look at the original, don't do this in your notes because you'll just make it a mess, but first times first. Isn't that what we did? X times a 2x, right? Isn't that the first thing we did? So there's the first. Outer terms. Didn't we then distribute the x times the 5 and did the outers? We did, right? And got the 5x. The inners, here are the inner terms. Didn't we do next the -3 times the 2x to get the -6x? We did. And didn't we finally finish up with the last terms of each binomial? And we did, and that's FOIL. First, outer, inner, last. Honestly, I think you're shortchanging yourself if that's how you do binomials. Because if that's your thinking, then every time you see a binomial, you're thinking first, outer, inner, last. You're not thinking distribute. And if you think first, outer, inner, last, that's fine for binomials. What are you going to do with polynomials? You're not going to. Now you got a whole different methodology. And here's the principle. Look, A binomial times a binomial is the smallest area where this principle is involved with. And we should learn it on the simplest, smallest. It's the simplest one. A polynomial times a polynomial is more complex. Let's learn it on the simplest one. Let's not learn a trick on the simplest one when we can learn the method on the simplest one. And that's what I want you to learn, the method. Now, pay attention to detail and pay attention to the order. That's important. You got to be orderly and you got to pay attention to detail. Okay, so let's look at our second one. Okay, so again, I'm going to distribute the first, right? The 2y times this back binomial. What's a 2y times a 3y? I hope you're thinking 6y squared. Now let's distribute the 2y times the negative 7. What's a 2y times the negative 7? I hope you're thinking negative 14y. Let's take our back 5 and distribute it. Positive 5 times a 3y. Positive 15y. Do keep my plus signs there just for clarity's sake. And what's your positive 5 times your negative 7? A negative 35. Finish it out by adding the like terms in the middle. And what do we get? Plus y minus 35 on that one. Okay? 6y squared plus y plus 35. Hey, these are not hard. These are not hard, not designed to be. Let's do another one. Now, again, if you want to do it on your own, pause the video. Go ahead and do it, and then restart the video. Okay, so 5a times a 7a. Hopefully you're thinking 35a squared. Distribute that 5a to the back term. Positive 5 times negative 2, negative 10, a times b, ab, right? Let's do the back distribution. Again, be careful. Keep the negative sign with it. Negative 4b times a 7a. A negative 28ba, but that's out of order. Let's put them in alphabetical order, A, B. And what property allows you to switch the order of the B and the A? And of course, I hope you're thinking of the commutative property, right? All right, so an AB and a BA are the same thing. We know that. All right, and let's make the last distribution. Negative 4b times a negative 2b. Negative 4 times negative 2 is a positive 8. B times b is b squared. Finish it off by adding the like terms in the middle. 35a squared minus 38ab plus 8b squared. Hey, these are easy. These are easy. All right, class, beware, 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 beware of this situation. Beware, beware. Students mess this thing up. How do they mess this thing up? All right, well, I'm going to show you. Don't write this next thing. I'm just going to show you why students get this wrong. We have a rule, x to the a to the b equals x to the a times b. And that rule is true, and that rule works, and it's beautiful. Again, don't write this. So if we had something like this, 2x squared cubed, or let's make it squared, 2x squared squared, you would say this is 2 squared, right? 2 to the 1 times 2 times x to the 2 times 2, or x to the 4th. Final answer, 4x to the 4th, right? And that's true. So students try to do that here. They try to distribute this squared. Here's the problem. You can't do it. What's the difference? Notice the difference. If you'll notice the difference, it'll help you to remember when you can and can't use this rule. Watch. Monomial. Monomial. Matter of fact, this rule is for monomials. Notice here, binomial. Uh-oh, can't use the rule. Binomial, trinomial, any polynomial can't use the rule, can't use the shortcut, the rule. You instead have to multiply it out. So don't make that mistake. Don't make that mistake. Don't make that mistake. Don't make that mistake. You say, so Mr. Scarfi, what do you do? Oh, it's easy. What does it mean to square anything? It means take the base and multiply it times itself, doesn't it? Right? Take the base and multiply it times itself. We know how to do that. Hey, what do you got left? Distribute problem. Okay. Front times front. 9x squared. Front times back, negative 21x. Back of the front term times the front, negative 21x. And negative 7 times negative 7, positive 49. Notice what our answer is. Our answer is a 9x squared minus 42x, right? 21 negatives and 21 more negatives, plus 49. Okay? Hey, be careful. I'm telling you, I see it all the time. How many times do I see students try to do this, and they try to... How many times do I see them just try to use the rule, and you can't use the rule, you can't use the rule, you can't use the rule. You got to multiply out the two binomials, okay? Be careful there. Students make that mistake all the time, and I'm trying to warn you. I'm trying to warn you. All right, let's go on. All right, so here's the thing. If you're a foiler and you foiled, what are you going to do now when you do a polynomial times a polynomial? Well, look, again, we've practiced how to distribute on the easiest ones. So now we'll do it on the little bit more difficult ones, and we'll just distribute. That's all we'll do. We can do this. We're just going to distribute. And we learned how to do it on the easiest ones. All right, let's take a look. Front term, I'm in red, right? Front times front. What's an x squared times a 2x squared? That's a 1 in front of the x, right? It's not shown. 1 times 2 is 2. X squared times x squared, x to the fourth. Okay, second distribution. X squared times 5x. 1 times 5 is a positive 5. X squared times x, x cubed. Make sure you keep your positive signs because it keeps things in order. Okay, that's a positive 5x squared. All right, it's not going to let me get rid of that, so let me just write it again. Positive 5x cubed. X squared times x, x cubed. All right, be careful. All right, third distribution. X squared times negative 7 is a negative 7x squared. Okay, we just made the first distributions. We're done with that front term. Let's go to the middle term. Again, be careful. This is a negative 3x. What's a negative 3x times a positive 2x squared? It's a negative 6, and the x is cubed, right? I'm going to put it in the cubed column. Negative 6x cubed. Don't I have an x cubed column? I do. That's where I'm going to put it. Look, pay attention to detail. These are the keys that make it easier on you. Pay attention to detail. All right, next distribution, negative 3x times a positive 5x. Negative 15x squared. Negative 15x squared. Again, I'm going to put it in the x squared column. Finish off the last distribution, this negative 3 times a negative 7. Positive 21x. Okay, let's do our last distribution. Here, I'll do these up top for clarity's sake. Positive 2 times a 2x squared. A positive 4x squared. And look where I put it, in the x squared column. Positive 2 times a 5x. Positive 10x. Again, keep the plus signs. You need them. Positive 2 times a negative 7. Negative 14. Now, because we paid attention to detail and because we've lined things up while we did the distributing, adding the like terms is easy. Front term, 2x to the fourth. Next term, 5 positives and 6 negatives of them leaves you 1 negative of them. What are they? X cubes. Next one. Negative 7 and 15 more negatives of them is a negative 22 of them. A negative 22 and a positive 4 is a negative 18 of them. What are they? X squareds. Next one. 21 of them and 10 more of them is 31 of them. And then you have the negative 14. Hey, we ended up with a polynomial with 1, 2, 3, 4, 5 terms. What degree is this polynomial? and hopefully you would think it's a fourth degree polynomial. Hey, be careful, because look, you have 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 multiplications you have to make. All right? You got to make 9 multiplications. There's 9 chances to make a mistake. Then you had to add like terms 3 times. So you have to add like terms 3 more times, so there's 3 more possibilities of a mistake. You got to go 12 for 12 to get this problem correct. You got to pay attention to detail in math. See, that's a shame, because if you're a little sloppy in what you do, you're going to miss one of those 12 things and you'll get it wrong. You might get 11 out of 12. So look, be careful. Pay attention to detail. It's a shame to miss a problem when you know what to do. You just made a mistake. Be careful. Methodology is important. Neatness is important. You sloppy people, you got to learn how to get neater in what you do, because your sloppiness leads you to mistakes. There's 12 things you got to do to get this thing finished. And so if you mess up on one of those 12, you're going to get it wrong. Be careful. It's not hard. Nothing we did was hard. Let's do another one. Again, I would pause the video if you want to. You can pause the video and do the problem yourself. I will tell you this, though. We have a trinomial times a binomial. We can distribute it the way it is. And we can do the, don't write this, I'm just trying to get you to think. The 2y squared times the 7y, the 2y squared times the 4, then the negative 3y times the 7y, and the negative 3y times the negative 4, and the 5 times the 7y, and the 5 times the negative 4. And we can distribute that all out, and that's fine. And that's how I'm going to do the problem. But I will tell you this, some students prefer to use the commutative property and switch the order. So some prefer to use the commutative property and switch the order. Okay? You can do that. How would you finish this problem? Distributing, right? Distribute, distribute, distribute. Distribute, distribute, distribute. See, we know how to do a binomial times a trinomial because we know how to distribute, not because we learned a trick called FOIL. Okay, so I'm going to finish this one up the way it's written. Distribute 2y squared times a 7y, 14y cubed. 2y squared times a negative 4, negative 8y squared. Middle term. Negative 3y times a 7y, negative 21y squared. Notice I'm putting it in the y squared column. Negative 3y times a negative 4. Be careful. Negative 3 times negative 4, positive 12 times the y. Last distribution in blue. 5 times a 7y. 5 times 7y is a 35y in the y column. 5 times a negative 4, negative 20. Let's add it all up. 14y cubed minus, right, 8 negatives and 21 more negatives, 29 negatives of them, y squared, plus 35, 45, 47 y's minus 20. Hey, we can do this. We can do these. We can do these. All right. One more example. Oh no, what do you do if you have 3 things? Okay, well, look, class. Here's thing number 1, thing number 2, I keep thinking of cat in the hat, and thing number 3. 3 things being multiplied. How would you multiply the numbers 1 times 2 times 3? Wouldn't you take 2 of them first and multiply them and get an answer, and then when you're done, multiply it times the third? Right? Isn't that what you do? Isn't that how you multiply 3 things? That's what we have to do. That's how we multiply these 3 things together. We're just going to multiply them in order. Okay, so what am I going to do? I'm going to take these first 2, and I'm going to multiply them. Okay? X times x, x squared. X times positive 4, positive 4x. Negative 3 times x, negative 3x. I'm lining them up, right? Negative 3 times a positive 4, negative 12. What does this become? X squared plus x minus 12. Now watch. parentheses. The box up above has become x squared plus x minus 12. That's the first thing times the second thing. Don't I have to multiply that times now the third thing? Do you follow? So again, let me just, before we go and before we finish, just watch. I'm taking the first two things and multiplying them together. When I'm done, I must multiply what I get from the first two things times the third thing. Here's what I got from the first two things. Now I'm ready to multiply it times the third. Are you with me? Okay? All right, so let me clear off these, and now let's finish. Let's finish. All right, I'm going to use color to finish. First term, let's distribute it, x squared. What would you do? I'm distributing it to the back binomial, x squared times 2x, 2x cubed. Second distribution, x squared times a negative 3, negative 3x squared. All right, do the middle in green. Positive x times a 2x, a positive 2x squared, lining them up in the x squared column. Positive x times a negative 3, negative 3x. Back term, negative 12 times a negative 2x, negative 24x. Negative 12 times a negative 3, positive 36. Finish by adding like terms. 2x cubed minus x squared minus 27x plus 36. There you go. How do you multiply three things? The first times the second. What you get from the first times the second, multiply times the third. So let me again remind you of an important aspect. You must add this parentheses when you're done multiplying the first times the second. Okay, that's very important. Look what happens if you don't add the parentheses. Here's what you would have had. X squared plus x minus 12, and then you would have brought down your 2x minus 3. And what do students do then? They only distribute this part. So they only take part of the front two being multiplied to multiply times third. That would be wrong. It must be the whole result, the whole product of the first times second to get multiplied times 30. All right, those are pitfalls, so beware of them. I'm trying to make you aware of them so you don't make them. All right, that's the lesson. Let me go back to where we started. Multiplying, it's easy. Distribute, use the distributive property. Remember, binomial times binomial, distribute. Polynomial times polynomial, distribute. Three things, first times second, result, product, times third. There you go. That's what you need to do. All right, key lesson. Come back to it again if you need to. And I hope you do well with it.